Hi students, welcome back to my YouTube channel SADHIK Physics, where you can learn physics very easily, right? So we already started one chapter, that is current electricity. Already we did 3 videos regarding the current and Ohm's law and resistors combination, and in this video we will discuss Kirchhoff laws. So what are these Kirchhoff laws and what is the use of this and where we have to apply? So these Kirchhoff laws, therefore there are 2 laws are there, so which can be applied in a circuit analysis. Therefore you can calculate the current, or you can calculate the potential difference. So therefore we can calculate very easily. So we can draw some equations to solve this one. So by using this laws, right? So let us see what is this Kirchhoff laws and applications and some problems we'll discuss in this video right? So if you did not subscribe, please subscribe to my channel and share these videos so that everybody can learn the physics very easily. Now let us see what is the Kirchhoff laws, right? So Kirchhoff laws. So there are 2 laws are given in the circuits, therefore so many complicated circuits will be there. In that 2 laws are there. One is so Kirchhoff current law, KCL, or sometimes you can call it as like a junction rule. We'll call it as junction rule, right? So Kirchhoff current law, right? So or a junction rule, so both are same only. So what is this one now, right? So like you might have seen so many circuits, so many wires are there now, that wires are getting joined at one point now. This is, we can call it as like a junction. So here there is some resistance is there, here it is some joint here, some resistance or some other things, most of the things, some, alright, some circuit parts are there, they are connected at this point, like this point now. So this is, we can call it as like a junction. So therefore here at this junction, therefore this is just like a connecting of these wires at this point. So can you tell me that so at this junction will that electrons will get disappear? No. So will the new creation of the electrons will take place? No. So therefore here how many number of charges are coming, that many number of charges are leaving. Therefore there is no creation, there is no absorption of the charges. We cannot able to create it, we cannot able to so destroy the charges now, right? So therefore at the junction, therefore there is no absorption of our charges, so there is no creation of the charges. That means how much amount of charges are entering, that much amount of charges are leaving. So that is nothing but our law of conservation of charge. So this is based on what? Law of conservation of charges, right? So that means at the junction, therefore total charge, which is total charge at the junction is always equal to 0. So therefore the charge per unit time, therefore we can call it as current, at the junction, total sum of all the currents at the junction is always equal to 0. So sum of all the currents at the junction is always equal to 0. Suppose some currents are which are entering. So suppose I1 is a current which is entering, I2 current is which is entering, some I3 current which is leaving, I4 which is current is leaving now. Therefore what we can write it now? So total current, total current at the junction, it is always equal to 0. That means so total sum of currents, it will be equal to 0. Therefore total sum of the currents which are entering, so that much sum of current are leaving now. Clear? So currents which are entering and the currents which are leaving, so therefore so it will be equal. Therefore how many currents are entering now? Therefore I1 plus I2, so can be written as I3 plus I4. So like this you can rewrite it as now, or by using this law, therefore we can calculate the junction potential. So therefore V0 is the junction potential, therefore V2 is the potential here, V1 and V3 and therefore V4. So you know that current is nothing but a potential difference by resistance. So suppose here I am take it as like a resistance is R1 here, no, this is your R2 and this is your R3 and this is the R4. Now I can rewrite it as, therefore the currents which are entering, so entering means this is higher potential, this is lower potential, so V1 minus V0 divided by, therefore here R1 plus, so V2 minus V0 by R2 is equals to, so therefore here from here to here is going mean this potential is higher, no, VO minus V3 by R3, so plus, so VO minus V4 by R4, so this is the right, so this is the current law we can apply it now. Therefore by using this formula we can calculate the junction potential also by using this formula now. Clear? So these formulas are slightly important now, so we will use this concept to calculate the junction potential. Clear? So this Kirchhoff current law, so it is based on what? Law of conservation of charge. This is most important. Clear? Next one, so therefore we can go for KVL, another one more, KVL, therefore current, Kirchhoff voltage law, or this we can call it as also loop rule, right? So therefore you have to take certain loop, no, therefore certain loop, no, within that loop the total potential difference, no, it will be always equal to 0. Therefore here potential will be same, no, potential will be 0, potential is nothing but a work done per unit charge, no, so this is based on law of conservation of energy, also sometimes we can rewrite it as conservation of the electric field, also we can rewrite it as, no. So now let us see, so here I will take one loop, no, therefore I will tell you some shortcut, no, therefore try to listen, no. So there is one loop is there, no, I will draw this loop here, or some here right. So suppose here this is one circuit is there, no, so I will write it as like a R1, therefore E1, so R2, therefore E2, R3, so therefore E3, E4, R4, therefore R5, like this is given, no. Therefore so can anybody tell me that how many number of loops are there in this one, no, right? Just pause the video and just comment it, no. So how many number of loops are there? Most of the 2 students they will tell that sir there are 2 loops are there, this is one loop, no, this is one loop, no, there are 3 loops are there. So this is one loop, no, this is second loop, no, this is your one third loop. Clear? So this is the 3 loops are there, we can develop the 3 equations now, right? So therefore here what it is telling now, it is therefore here for one complete loop, no, therefore total work done it will be equal to 0, so that means the total potential difference current in the loop, no, it is always equal to 0. Clear? Therefore here total work done throughout this one complete closed loop, no, so it is lead to the 0. This also lead to the conservation of electric field is nothing but a conservative in nature, no. Clear? So now okay, how to apply this loop, no, how to apply this KVL equation, just 2 minutes or 3 minutes, just concentrately listen, so slowly you try to listen, so that you can do any type of questions, you can apply the KVL very very easily without memorizing anything now. Clear? So first you remember that therefore current will flow from higher potential to lower potential. That means suppose there is some potential, some resistance is there, no, here the current is flowing now. Current is flowing means indicate is what, no, it is indicate that here, therefore here current is flowing from here to here, suppose A and B, current is flowing from A to B, that means what is happening now, this VA will be greater than, so VB, correct? Then only the current will flow, higher potential to lower potential. Now suppose if you are going from here to here, A to B, so therefore what is happening now, you are going from higher potential to lower potential. Higher potential to lower potential you are going means you are losing the energy, so therefore you are treated as potential difference is nothing but a minus V, that is nothing but a minus, so therefore IR, you should write it now. Clear? So you are decreasing the potential, no, therefore you should write it as minus IR. Clear? Suppose if you are going from B to A, therefore B is lower potential, you are going to the A, you are gaining the potential, no, at that point. Suppose if you are going from B to A, so therefore you are going from lower potential to higher potential, so then you should write it as plus IR, your potential is increased. Clear? Or there is a cell is there, now this is one cell, no, so this bigger terminal is nothing but a higher potential, this smaller terminal is nothing but a lower potential. Suppose if you are going from here to here, this is an EMF, no, so you are going from higher potential region to lower potential region, potential is decreased, so you need to write it as minus E. Suppose if you are going from, right, so negative to positive, therefore you need to write it as plus E. Clear? So these are the things, no, you need to remember this one, no, therefore then you can apply it now. Okay, so this point, no, very very important. If you do not understand, please again you try to listen, no, so that you can will not get any problem now, right? So next what you have to do now, you need to, so first of all arrange the currents now, therefore you just split the currents now. So sir, I don't know how to apply, therefore you randomly you apply, no, therefore some current, no. Suppose here I am thinking that here therefore the current will be going from here to here, right? Suppose here this is the I current which is coming here, no, I current only will come here, I current, but when it comes to here the junction is there, so therefore here suppose I1 current is going to this side, no? This side the current it will go how much now, I minus I1 current it will go. So this I1 current is coming here, no, therefore here, so this is here I from this I1, okay, so therefore here it is coming now, therefore I minus I1, so therefore here I can write down I minus I1, so therefore here, right, so therefore here now also this is here I minus I1, so this I1 is combined, therefore again I it will go. Okay, I applied here now, really I don't know which one it is going in this direction now, right? So now what you have to do now, okay, you have to apply, you have to solve it now. So suppose if your answer, current for answer I you got it as negative, so this I value you got it as negative, therefore your chosen direction is wrong, so therefore here we choose this direction, no, if your answer get negative, no, therefore the direction was in this direction now. So if your I answer got positive, so therefore your chosen direction is correct one, no, so therefore you can align it, right? So in this way just you can align it, no, so therefore you can, after aligning what you have to do, you need to apply the KVL equations now. How to apply? So therefore you need to travel along the loop, no. So now what I will do now, so first of all I will travel along this one, no, like this. Okay, sir, why like this? You can go for like this also, clockwise, anti-clockwise, your wish, no. So suppose I am traveling like this, no, therefore this is first loop, no, so I am traveling like this. Now what I can do this one now, therefore I will start from here. So suppose I am starting from here, in which direction I am going, listen carefully here. Suppose 1 or 2 minutes it will be there, just listen concentrately so that you can easily you can do these questions now. Suppose if you are going from here to here, so therefore you are going from higher potential to, lower potential to higher potential, means you are gaining the potential, so therefore plus E4. Clear? So now we are going from here to here, so I am going from here to here means current is also going, that means this is your higher potential, this is your lower potential, but that means you are going from higher potential to lower potential means loss, so therefore minus I1 into R5. Now I am going from here to here, negative to positive, so therefore here plus E1. So now I am going from here to here, that means here, so I am going from higher potential to lower potential, therefore higher potential to lower potential means decrease. Clear? So minus I into R1, therefore also here I am going from, therefore I am going from here to here, so higher potential to lower potential minus, so therefore minus I into R4. So now I came to here, no, therefore total potential difference it will be equal to 0. I think you understood, no, how to write these equations, no. Therefore you might have studied in right school level by the memorying and anything, no. So please you try to understand like this, you can write it now. Clear? So therefore if you do not understand, just listen one more time, no. Therefore again, right, one more time I will explain, no. So just listen here so that you can understand very clearly. Here I travel like this, no? Now I will travel like this. Sir, why sir? Your wish, no problem. Right? For your difficulty level, I will go for this one. Now I will start from here. I will start from here. Now I am going from here to here. So therefore I am traveling like this, no? I am going from here to here. So that means current is traveling in which direction? No? Current is traveling from here to here. This is a current direction, no? But where I am going now, current direction means this is higher potential, this is lower potential. Current direction is going. So therefore, where I am going now, I am going from here to here. That means lower potential to higher potential. Gain is there. Therefore, what I can write it now? Plus, what is the current now? I minus I1 into R2. Clear? Now, again I am going from here to here. Therefore, plus terminal to negative terminal, no? Decrease. Therefore, minus E2. So again I am going from here to here, current is going like this. So therefore that means this is your higher potential, this side it will be the lower potential. But what I am doing now, I am traveling from lower potential to higher potential. Gain means plus I minus I1 into R3. So now I am going from here to here, higher to lower, therefore minus E3. So therefore again I am going from here to here. So in this direction only the current is traveling now. Therefore, this is your higher potential, this is your lower potential. Going from higher to lower, minus. So minus I1 into R5. Now I reach to this point now. Therefore, equal to 0. So, right. So in this way, therefore you can able to write the equations. So this is right. If you do not understand, they are if you right. Right. So here, right. So therefore, again try to listen the video very slowly so that you can get every clarity in this one now. Clear? So this concept is very important now to solve the equations. Clear? Or to solve the circuits now. Clear? So by writing these equations now, you can solve this one now. So as a homework, no, therefore try to write this right equation, no, try to travel like this. So just to try it, no, like this. Clear? So try like this, no, so that what you can get it, no, you can get it as this. Clear? So try like this, so then you can able to solve the equations one more equation you will get it now. Clear? So try to comment it now, so that you can I can also understand that you are understanding these concepts now. Clear? Now we'll apply by using these equations now, we'll apply the for the circuits now, so that you can able to solve it now. Let us apply this one now. So let us do some questions. Clear? Right? So therefore this is one calculate the values of I1, I2, I3, I4 in the section of this one. This one section is given now. Clear? So therefore here what you have to do now, therefore here 15 amperes is coming now. Therefore 15 amperes is coming. So from this one now, therefore what happened now, this side 8 ampere is going. 8 ampere is going means this side. So therefore 15 minus 8. 15 minus 8 means, so therefore 7 ampere now it will be going to this side. So therefore I2 I got it as 7 ampere. Now 7 ampere is coming here now. Therefore here 3 ampere is getting added. So that means this side 7 ampere is coming and this 3 ampere is adding. Therefore it is coming to this side now. 7 plus 3, therefore 10 ampere no. So this is I3. I3 is how much now? 10 ampere no. This one. Clear? So 10 ampere. Now this 8 ampere is coming. So in this one now, this side 1 ampere is going, this side 5 ampere is gone, 8 ampere is coming. Therefore this should be compulsory 3 ampere. Therefore I4 I got it as 3 ampere now. So this 3 ampere is coming, this side 10 ampere is coming. Therefore here both are added to this one now. So this is I1 is nothing but a, so 13 ampere no will be your answer. Clear? Right? So here it is like a KVL, KCL equations. Now we'll go for one more question. Right. So therefore initially switched on, switch is open. Now when the switch is closed, find the current passing through it. Okay. So therefore here what you will get it now, well, let us calculate the potential at this point, no, potential at this junction, no, VO we will calculate it now. So therefore here you know that suppose here A is there, 2 ampere is there, therefore current it will be flowing here now. Therefore here also 5 volts and 4 ampere is your current it will be flowing. So here this is 0 volts, no, therefore now the currents are coming to this side now. Therefore suppose this is here I1 and I2, so this is nothing but a I3. So I1, I2, so therefore I3 is nothing but a I1 plus I2, clear? So I3, so what you can write it now, okay, or just you can add these two. So therefore I1 is what is nothing but a potential difference. We don't know the potential difference here now. We will calculate the potential, so then we can, okay. So we will apply this one now. Therefore here I3, so therefore VO minus 0 divided by 2 ampere, this one now. So I1 is nothing but a 20 minus VO by 2 plus, so this is nothing but a 5 minus VO by 4. Then we can solve it now. Therefore here, so here I can make it like a 4, and therefore here VO by 2 is equals to 20 minus VO by 2, or we can, I can split this one, no. Therefore here 20 by 2 minus VO by 2 plus 5 by 4 minus VO by 4. So how much I can write it now? Therefore this all I can take it here now. This implies, so VO by 2 plus VO by 2 plus VO by 4, it will be equal to, so therefore I can multiply with 2, so 40 divided by 4, so 45 by 4, clear? So therefore here it is 2, this is VO, so 4 VO by, therefore 4 VO by 4 plus VO by 4, it will be equal to 45 by 4. This cancel, no? Therefore VO, 5 VO, so 45 divided by 5, 9 volts will be your answer, right? We got it as junction potential is about 9 volts, I got it now. So how much now? 9 volts. And is asking what is the current here, no? So the current through this one now, this I3 is nothing but a, this potential difference by resistance, no? Potential difference is nothing but a 9 minus 0. So because 9 and 0 by 2, therefore here it will be 9 by 2, 4.5 ampere now. This is the current which is flowing through this switch onto this, clear? Right? Now we will go for one more question now. Find the current through the 12 ohm resistor now, right? So he is asking current through the 12 ohm. So now here about 15 volts, therefore here 2 volts, 3 volts, 4 volts, therefore definitely higher voltage, no? This is suppose I1 is the current, no? So this is one junction here, no? Junction potential. From here I2 current it will flow, I3 current it will flow, I4 current it will flow, because these potentials are lesser than this one. I can rewrite it as like a I1 is equals to I2 plus I3 plus I4, clear? Now therefore we can go for potential difference, no? Therefore here we can apply. So from here to here it is going 15 minus V0 by 12. We don't know, therefore without finding the junction potential we cannot calculate the currents now. So I2 is nothing but a V0 by 2, V0 minus 2 by 6 plus, so V0 minus 3 by 4 plus V0 minus 4 by 8, clear? Right? So we can simplify it now. Therefore 15 by 12, So minus V naught by 12. So is equals to V naught by 6 minus 2 by 6 plus V naught by 4 minus 3 by 4 plus V naught by 8 minus 4 by 8. So this minus V naught will take all this one toward this side. Therefore 15 by 12 plus 2 by 6 plus 3 by 4 plus 4 by 8 is equals to, so V naught taken common 1 by 6. So plus 1 by 4 plus 1 by 8, this taken plus 1 by 12. Clear? So therefore here I can just simplify it. Therefore here, so 3 4s are 3 5s are, so 2 1s are 2 3s are, 4 1s are 4 2s are, this one. So therefore here it is nothing but a 5 by 4 plus 1 by 3 plus 3 by 4 plus 1 by 2 is equals to V naught, right? So here 1 by 6, this I can rewrite it as, so LCM is nothing but a 8, so into 12. Let us see here 6 4 8 12. 4 I can write down, therefore 1 2 3 6. So 3 I can write down, 3 2s are 1 2 1. So this is 12 4 12 12 into 48, 48 should be our this one. So therefore here this is 6 means this side I can multiply with 8. So this is 4 means I can multiply with 12. So 8 means I can multiply with 3. So 12 means I can multiply with 4. So 4 3 12 8. Clear? So 8 12 20. So 27. 27 by 48. Clear? Here also I can make it as like a, this is 2 gone here, 12. 12 I can make it, therefore this is 3. So this I can make it 4 into 4 into 3 into 6. So 15 plus 4 plus 9 plus 6 divided by 12, it will be equal to V naught into 27 by 48. How much it will be? 12 1s are 12 4s are. So how much it will be? Here it will be 15 15 30 34 into 4 by 27. This is nothing but a V naught. V naught is equals to 16 1 12 13 136 by 27 volts. So this is your junction potential now, right? So slightly lengthy we got it now. Now therefore we want to calculate the current here now. Therefore how to calculate this I1 now? So this I1 is nothing but a 15 minus V naught. V naught is nothing but a 136 by 27 divided by the 12. So simplify this one, this it will be your answer. Clear? So now we'll go for another question now. Right. So find the current through the branch of BD. Okay, this through this one now. So first of all, is asking the current through this one now. This current I want to calculate it now. First of all, what you have to do now, you need to assign the currents now. I'll take the current which is flowing here now. This is your I current which is flowing, I. So when it comes now, therefore I1 it will go here, I minus I1 it will go here now. So therefore I minus I1 it will come here now. So therefore this I1 it will come no, therefore cancel out no. So this is your I. This is the currents no, I allocated. I don't know whether it will positive or negative no, therefore we'll see whether the current is going like this or like this, I will see. Clear? Now therefore we'll apply the KVL here no. So here I will apply like this no, therefore now we can apply the first equation no. what I will do it now, I will start from D. So going from here to here like this. So current is coming from here to here. This is your higher potential. This side it will be your lower potential. Sorry. Current is coming from here to here. Means this is your higher potential. This side it will be a lower potential. Where you are going now? You are going from lower to higher. Means gaining. Gaining means how much now? Plus 3I1. Now I am going from here to here. So therefore here the current is going from higher to lower. Current is going this direction, higher to lower. I am going from higher to lower means decrease. So minus I1 into 6. So now I am going from here bigger terminal to lower terminal, minus 15. No? So there is nothing, it is there. This is 0. Clear? So this is, we can simplify this one. No? Therefore it is 3I1 minus 6I minus of minus 6I1 minus 15 is equals to 0. So therefore 9I1 minus 6I minus 15 is equals to 0. Clear? So now we will go for another one more. Here I will travel like this, no? For your convenience. Whatever you want to do, you do it now, right? So what I will do, I will start from here only. So therefore I am going from here to here. Here to here means lower potential to higher potential. Gain of this one, no? Gain means plus 3I1. Now I am going from here to here. So current is coming from here to here. That means this is your higher potential, this is your lower potential. I am going from lower potential to higher potential. So gain, therefore plus 3I. Now I am going from here to here. So therefore here 30. So therefore minus 30. So then there is nothing is there. It will be equal to 0. So therefore I1 plus I minus 10 is equals to 0 because I took the 3 common. So what I want to calculate? I want to calculate I1 only. I should eliminate it now. Clear? So therefore here I can be written as here 10 minus I1. So substitute here now. What you can get it here now? Right? So 9 I1 minus 6. So 10 minus I1 minus 15 is equals to 0. So 9 I1 minus 60. So plus 6 I1 minus 15 is equals to 0. So this it will be the 75. This it will be the 15 I1 is equals to 75. I1 is equals to 75 by 15. So therefore 15 5s are 15 1s are 15 5s are. So 5 ampere plus only I got it, no? Therefore what I choose the current, no? It correct direction is same. So I got I1 is nothing but a 5 ampere. So my answer got positive, therefore I choose the direction is correct only. Clear? So in this way you need to solve the problems now. Clear? Now let us go for one more question now. Right? So find the equivalent resistance across AB. Here this type of solving, no? Therefore here you can check it as symmetry. I already told you in the previous video. So therefore here we want to calculate it, no? So therefore if you draw this one, no? Therefore this is like a symmetry here, no? So symmetry means therefore symmetry. So therefore here, so current divisions it will be the same, potential difference it will be equal to 0. So current it will be equal to 0. So therefore resistance is ineffective. So that means can neglect it. Clear? So therefore here right? So therefore I told you this is one Wheatstone bridge, no? So therefore this can be neglected here, no? Therefore in that way also you can rewrite it as. So now just I can just modify it, no? Therefore I can rewrite it as. So this is one resistance, no? Another resistance. Here another resistance. Here resistance, no? Here one more resistance. Here one more resistance. So these two are in series. Therefore R. So therefore these two are in 2R, but these three are in parallel. So RAB is equals to 2R by 3 will be your answer. Clear? So now we'll go for another concept now. Right? Here right, we'll see this question now. Here also looks like a symmetry here, no? Therefore, here it is AB we want to calculate. So we can draw the symmetrical line here, no? Therefore, this is one symmetrical line. So therefore, it is equally divided. You can see these two parts, no? Equally divided. So this part no and this part no. Therefore, equally divided here, no? Therefore, so this part is said to be like a symmetry, which is drawn perpendicular to this one, no? This symmetry indicates like a equipotential line. Equipotential line means what? Potential will be same. That is nothing but a potential difference. It will be equal to 0. That means current it will be equal to 0. So in the along the line of symmetry, therefore, if any resistance is there, we can remove it now. If any junction is there, we can remove it now. So if resistance or a junction it is there, no, therefore we can remove it. So in the previous question, no, we removed the resistance, no. Here there is a junction is there at this point, no. So this junction can be removed. Clear? Huh? Then I can rewrite the circuit, no, right? So here this is now, so this is clear. So now here it is like this, therefore now this part is just there, no. So we can remove it, no. Right? So here this is B, this is A. Now you can solve very easily, no. Therefore here everything is R. These two are in series, no. Series means what will happen now? This is 2R and this is parallel to this one, no. 2R into R by, therefore 3R get cancelled out, no. 2R by 3. So this part will become like a 2R by 3 and this part it will become like a 2R by 3. Clear? Therefore here what you can write it now? So this is R and R. So this is R and this is R. This also R and R. So what we can rewrite it now? Therefore here now, so therefore here this branch, no, I will write it now. Therefore R equivalent along this one, no. Therefore 2R plus 2R by 3. So therefore here it is 6R, 6, 7, 8, 8R by 3. So this is here 8R by 3, this is 2R. Therefore 1 by R equivalent is nothing but 1 by 2R. So these two are plus 2 by 8R into 3. So therefore here it is 4R can be written as, so here also 2, therefore here 4R. So 2 by 4R plus 3 by 4R, 5 by 4R. Therefore R equivalent is nothing but 4R by 5. It will be your answer. Clear? So therefore this is about like a symmetry problems, no. Right. So in this way you can solve these problems, right? Now we'll go for another question, no? Let us see. So therefore here we want to calculate the reading of ammeter and voltmeter if the switch is open and then closed. So if the switch is open condition, now what we can see it now. Open condition, what will happen now? There is no connectivity, it will be there here now. So therefore here, so the circuit it will become like this one, no. Therefore this is 1 and these two open means there is no current, it will flow. So the current it will be able to go through this one, no. Therefore these two are in series. So this it will be the 8 ohms and this also 8 ohms divided by this one, no. Therefore this it will become like a 4 ohms. Now this is here 20 volts. Therefore here ammeter and voltmeter, no. Clear? Right. So therefore here current what will be flowing through this one, current will be, so 20 divided by 5, so therefore 4 ampere will be flows, right. So therefore here I it will be equal to 4 ampere. Now 4 ampere it is going 4 into 1 therefore here 4 volts it will be the voltmeter reading. Therefore, so when open is there therefore current is nothing but a 4 ampere and voltmeter reading is 4 volts. Now therefore here if it is closed, right. So therefore here now therefore switch is closed. When the switch is closed means what will happen now? So this it will become like a one short circuit here now. These two are connected at this point now. Therefore how the circuit will be happen here now? So this is 1 ohm and here this it will become like a, here this it will be connected here now. This it will become like this 20 volts. So this is 2 6 and 6 2, clear. So this is just connected, this is the junction here. So this it will be your ammeter and this is nothing but a voltmeter. First let us calculate this one. So these two are in parallel, so therefore 6 into 2 by 8, so 2 1s are 2 4s are 2s are, therefore 3 by 2 3 by 2. Therefore here what will happen now? This is nothing but a 1, so 3 by 2 into 3 by 2, this is 3, so therefore here, so this is 20 ammeter. Therefore here what is the current? Current it will be equal to 20 divided by 4, so 5 ampere So therefore here ammeter reading will be 5 ampere, voltmeter reading is nothing but 5 volts. So therefore in this way, right. So this switch in between this one if it is closed, so what is going to happen? You can understand. Clear, right. So now let us see some more questions now, right students. Therefore here there is a cube type of questions frequently they are giving the examination So therefore in this one there are 3 chances are there, so they can give the questions to calculate the equivalent resistance So therefore the method and everything it takes lengthy. So here just I suggest you to remember, okay. So how to remember also I will give small trick onto this one here. So first let us go for across this one Therefore here first one is nothing but along the edge, therefore resistance along 1 2, therefore here only I will write it So resistance along 1 2 and they may ask you along the phase diagonal therefore is in 1 3 and main diagonal also they can ask 1 7. So this is your main diagonal. So this is nothing but a phase diagonal. This is one of your edge, one of your side, okay, right. So edge or there is one side, clear. Edge also you can write it, clear. So what are these one? Just remember this one, okay. Edge and phase diagonal and main diagonal. So therefore electronic FM you can remember this one electronic FM, clear. So how to write these answers simple one So this derivation it will be goes lengthy. So if anybody want please just comment me. So if you want I will explain again here right. So just write down here. So therefore here right. So you can take the fraction here So here 1 2 therefore 3 4 5 6 7. This is equivalent resistance like this you can write down. This is your electronic FM, you can take it So therefore E is nothing but a edge, F is nothing but a phase diagonal, M is nothing but a main diagonal. So therefore here you can take a ratio 1 2 3 4 5 6 7 like that you can write it then you can get your answer. So just try to remember. So practice So this type of things practically they will ask directly the questions only. So just remember this. So along this diagonal, no, therefore it will be around 7 by 12 R, and along this one, no, therefore here along this one, no, therefore it is 3 by 4 R, therefore along this one, no, so therefore 5 R by 6. This is your answer. Clear? Right? Remember this? Right? Now we will go for another question now. Right, students, we'll solve this question now. Okay. So what is given this one now? Here the value of the resistors to be connected between CD, okay, so that the resistance of the entire circuit between AB does not change with the number of elements or sets are used. So like this, any number of sets are used, no, does not should be changed, no. So how much resistance should be connected, no? I will take it as like a suppose R naught, so that the resistance between this one is also will become like a R naught. If it is become, no, how many parts are connected does not matter onto this one, no. So therefore we can solve this type of circuit, no. Then also here this is infinite circuit is there, no. Therefore how to solve this infinite circuit, no? Let us see, right? Also here it is repeating. Which repeating now? This is 1 3, this is 3, this is 3, this is 3, this is 3, like that, no, it is repeating, no. Therefore what I will do now, just I will disconnect it from here to here, right? So now what I will do it now, therefore here there will be, so therefore here this is your AB, so this is your R, and this also R and R. So this is entire thing, it will become like a R naught. See how many parts are there. So therefore if you disconnect it, no, it should become like a R naught only. So now therefore across this also should be equivalent of this one also should be equal to R naught. We want to calculate this R naught now. So how it is there now? These three are in series. I mean series means what? So therefore here what will happen now? This it will become like a R, and this it will become like a R naught plus 2R. Clear? So this it will be also nothing but a R naught. Clear? Now these two are parallel, no? Therefore R naught is equals to A into B. So R naught plus 2R into R divided by R naught plus 3R. 2R plus R. Clear? Now just you can take this one, no? So this side, so R naught square plus 3R into R naught, it will be equal to R naught into R plus 2R square. So this taken here, no, R naught square, so therefore plus 2R into R naught minus 2R square will be equal to 0. Clear? Right? So here what you can get it now, therefore R naught square plus 2R into R naught minus 2R square. Therefore here I can it is like a R naught value only we can calculate, no. So therefore here we can use like a quadratic equation, no? Therefore R naught is equals to minus B plus or minus B minus this is B, therefore 2R plus or minus under root B square 4R square minus 4 A is nothing but 1, so minus 2R square by 2 into 1. Clear? So minus B plus or minus under root B square minus 4AC, like that, no. So therefore minus 2R plus or minus under root. So here what you will get it now, this is here 8, 9, 10, 11, 12 R square by 2. So therefore here I can write down 4R square means 2R can taken out, no, minus 2R plus or minus 2R into root 3 by 2. So here all R naught should be positive. Positive means this positive value. So 2 to cancel, no, R root 3, 2 to also cancel, no. Therefore minus R. Clear? So therefore R into root 3 minus 1, this it will be the R naught value. Clear? Okay. So second option will be your correct answer. Clear? Now we'll go for one more question. No? Right. So here, so we want to calculate I. So therefore here only we can solve it. No. This is 10 ampere is coming. No. So here 6 ampere is going compulsory. This should be 4 ampere. This 4 ampere and 1 ampere is added. No. Therefore this should be 5 ampere. Here 6 ampere is coming. So this 2 ampere is added. 8 ampere it will be there. No. So therefore 8 plus 5, therefore 13 ampere will be your answer. Clear? 13 ampere will be your answer. First option. Clear? Now we'll go for one more question. No? So therefore here is asking what will be the current across this BD. So here I will take it as this is your current I. So current I. So this is current I1, therefore I minus I1. So therefore here I minus I1. So taken here, no, therefore here it will be the I, here I. So I think exactly I solved this type of problem, no, therefore here, but values are different, no. I think I solved this type of problem. So once you check it here, here, so here 3 ohm, here 6 ohm, here 15 and 30 ohms are there, exactly how I solved, no. So like that you can solve this problem, exactly, the values are changed, that's all. So rest of everything it will be the same only. So just solve it, no, so that I can go for next part. I don't know what is that answer also, so check it, okay. So now let us see here, no, this is one question. He is asking what find the current across the 10 ohms resistor. Therefore current across this one, no, we want to calculate 10 ohms. Clear? So therefore here what I will do, no, I will just simplify. Current it will be flowing here, no, current I. So through this one, no, splitting here, no. So therefore suppose this is I1, I minus I1. So this I1 is coming, no, therefore again I it will be the. Now we can apply the KVL equation across this one, no, KVL across this one, no, therefore you can solve it. So in this circuit, no, what I will do, I will apply the KVL equation in this way. Now I will start from here, so therefore I am going from here lower to higher, therefore plus 4.5. So I am going from here to here, I is the current which is flowing. So what I am doing now, I am going from here to here, so higher potential to lower potential. This is your higher to lower, current it will be flowing, no, therefore but I am moving from higher to lower means decreasing, no, minus 3I. So therefore again I am going from here to here, therefore here, so lower to, current it will be flowing, this higher potential, lower potential, I am going from higher to lower means decreasing, no, I minus I1 into 6, so is coming, it will be equal to 0. Therefore 4.5 minus 3I minus 6I plus 6I1 is equals to 0. So therefore here 6I1 minus 9I, so plus 4.5, it will be equal to 0. Clear? So therefore here I can take it out common of 3. So 3 2s are 2I1 minus 3I plus 1.5, it will be equal to 0. Right? So now we will apply here, no? Therefore here we can start from here. So therefore I am going from here to here. So therefore minus 3 to plus 3, therefore minus to plus. So here the current it will be coming. This is your higher potential, lower potential, but what I am doing now, I am going from lower to higher means plus. So therefore plus 10 I1. Now I am going from here to here, higher to lower, minus 6 into I minus I1, it will be equal to 0. So 3 plus 10I1 minus 6I plus 6I1 is equals to 0. So therefore here's minus 6I plus 16I1 plus 3, it will be equal to 0. What I don't want now, I don't want I want I1 only. So I should eliminate it, no. Therefore I am taking I here, no. So therefore 3I, it will be equal to 2I1 plus 1.5. So I is equals to 2I1 plus 1.5 by 3. Clear? So substitute here, no. What you will get it now? Here minus 6, therefore I value is nothing but 2I1 plus 1.5 by 3 plus 16I1 plus 3 is equals to 0. Therefore 3 ones are 3 twos are. So therefore minus 4I1 plus 3, sorry, minus 3. Why minus or minus? Minus 3. So plus 16I1 plus 3, it will be equal to 0. Right? Right? So this is plus and minus will get cancelled out, no? Therefore I1, it will be equal to 0. Because here 12I1 is equals to 0. Whether I did any mistake? Okay. So I got it, no? But you understood, no? Therefore the concepts, no? So you try to solve, right? If any time mistake is there, no? Just you find it and just comment me. Clear? Right. Now let us see here, no? In a circuit, therefore, if the potential at point A is taken to be 0, right? Potential at point A, therefore this is 0. So the potential at point B, therefore here in this part now I can go from here to here to here, therefore I want to go. So therefore here I can apply, therefore potential at A, so this is 0. I can travel along this direction, no? Currents are there directly, no need to think. So this is 0, therefore here I am going from higher to lower, lower means minus 1. So therefore here I am going 1, therefore here 2 ampere is coming now. I don't know the ohms. Okay. Instead of here this resistance I don't know, so then I cannot go to this like this, no, right? So then I should go from here to here. Clear? So therefore here I1 it is going to this side, therefore 2 is coming means compulsory this side is also 1 is coming here now. 1 ampere is coming here now. Clear? So therefore here 2 ampere it will be there. Okay, right. Now we will go from here to here, higher to lower, therefore minus 1. So then I am going from here to here. Here to here means current is coming from here to here means this is higher potential, this is lower potential. But I am going from lower to higher means compulsory plus. Plus here 1 into 2. Then I am going from higher to lower, therefore minus 2 is equals to VB. So therefore here VB is equals to, so therefore here what I will get it, no? So 2 minus 2 get cancelled out, no? Therefore VB is equals to minus 1 volt. This it will be your answer. Clear? Now we will go for another question, no? Okay, same type, just some part of the circuit it is given here, no? Now he is asking potential difference between A and B. So I am starting from here, I am going in this direction, no? Therefore VA. So here 2 ampere, therefore here this is a direction, no? So that means this is a higher potential, lower potential, higher to lower, negative. So negative, lower, therefore minus 2 into 2. So here I am going higher to lower, therefore minus 3. Here also I am going from higher to lower, therefore minus 2 into 1 is equals to VB. So VA, so therefore here minus 4, minus 3, 7, minus 9 is equals to VB. So VA minus VB is equals to plus 9. Plus 9 volts will be your answer. Clear? Right? There are actually here 12 wires are there, each having the resistance is 2 ohms, are joined to form a, like a cube. Okay. Right. Therefore, a 6 volt battery is given now. EMF is joined across the points of AC phase diagonal now. The potential difference between a EF is asking potential difference between this one now. Right. So therefore, suppose here now, therefore what is happening now? Here the current, it will be flowing here now. I is the current now. Then current, see here, the current is getting divided, and these parts are also, this is your current, this is the current, this is the current which is divided now, and so this current now, therefore what will happen now? Again here this currents now should be able to enter here now. So this current, it is coming here to here, means this wire, so this EB wire can be neglected now, and here the current is coming now, therefore DG wire got neglected now, therefore here no, this current is coming, therefore again this current, it will be get divided here no, this part, right, again these parts are joined, therefore this part and this part can be removed. Clear? So then what you will get it now? Therefore here okay. So first let us go for current drawn from the battery. I can rewrite it as current drawn from the battery. Here phase diagonal I already told. So 3/4. So therefore here resistance, it is nothing but a phase diagonal. So 3/4 into R. R is nothing but a 2 ohms. So therefore here 3/2 ohms. Therefore current, it will be equal to potential difference by R equivalent no 6 by, so therefore it is 3/2, so therefore 4 ampere current it will be coming here now. So this is a 4 ampere current, it will be drawn from the battery here now. Therefore he did not ask what is the current now, therefore he is asking what is the potential difference here now. We will see here one diagram here now. So therefore here right. So here right. So in this one now, therefore which resistance are ineffective, means this resistance are ineffective. Okay. So here, right, here 4 ampere current it is coming now, 6 volts. Friends, we know that we got it as like a 4 ampere current, it will be flows now, but this 4 ampere it will be how it is going to divided. So here this also 2 ampere, I mean 2 ohm. So how it will be divided? Then we want to calculate the potential difference across this point now. This point now we want to calculate. Therefore this 2 ohm already is there now. Therefore if you calculate the current passing through this, then you can calculate the potential difference across this point now. So now let us see here how can be able to do it, right. So now just simply I will redraw the circuit now. Therefore here, so this is here 6 volts, 4 ampere. Now this part no, therefore here it is there, this is, I can take it as like a 4 ohms, right. Here also this side it will be the 4 ohms, and this point no, right, I will take it as right? So therefore here this is 2 ohms, and again this side it will be the 4 ohms, 4 ohms, clear. So in this way, therefore here, right. So this is the circuit part now. Okay, here also therefore 2 ohms, 2 ohms. Now the current now, how the current it will be divided now? Suppose here this it will become like a 2 and this it will become like a totally 6. Clear? First we should know it. Here the current which is coming here, no? Suppose 4 ampere coming, you know, therefore current it will go here. Suppose I and I dash, because here the current it will flow equally divided here, no, and this current, no. Clear? Right? So here just we can rewrite it as this is here 4. We want to calculate ultimately current in this one now, right? Current means this current now. So this is nothing but a 2, therefore total is 6 now. Therefore here this is here 6 volts and this is here 4 ampere, and here so this it will be right. Okay, so let us take this is here 4 ohms, 4, this is 2, therefore here it will be the 6 ohms. Therefore the current now it will be get divided here, no, right? So we know that, no, therefore the potential difference across this one, across this one, across this one, it will be the same. Clear? So potential difference here now, what you will get it now, here it will be this current across this one now, 6 volts only, current I it will be taken now, I, so 6 by 4, therefore 3 by 2 ampere. Across this one is 3 by 2, across this one is 3 by 2, so 3 by 2, 3 by 2 means 3 ampere it will go, therefore here 1 ampere it will comes out. So through this one now, therefore current it will be coming as like a 1 ampere. Now this current is coming, therefore again it is equally divided now, therefore it will be half ampere now, here also half ampere current it will be flowing. That means through this one now 1 by 2 ampere current it will be flowing, 1 by 2 ampere current is flowing now. So therefore through this one also 1 by 2 ampere now, therefore potential difference across this one now, therefore potential difference across, so therefore EF can be written as half ampere into 2 ohms, therefore it is nothing but a 1 volt. So therefore answer you are going to get it as like a 1 volt, it will be your answer, right? So this is one of your JEE main question, no? So this is your JEE main 2025 question, no? So keep in mind. Clear? So now, right? So thank you for watching. I hope I already covered almost all the concepts, no, right, which is related to the KVL and KCL, right? So I hope you learned Kirchhoff laws, no, through this video, no, right? Thank you for watching. If you do not subscribe, please subscribe and share these videos, no, so that others also can learn the physics very, very easily. Thank you.